Now we're going to go ahead and do powers of complex numbers in polar form specifically. But notice how the instructions say to write our final answer in the form a plus bi. Currently we're in polar form, also known as trigonometric form. We eventually need to get it into standard form, but let's do the operation first. It's always easier to do this operation when you're in polar form. So what I'm going to do is I'm going to go ahead and take the square root of 3 and raise it to the 4th power. And then this rule says that you're going to multiply your angle by 4. So 4 times 15 degrees. The square root of 3 raised to the 4th power is 9. And then 4 times 15 degrees is 60 degrees. Now, when we convert this into a plus bi, usually that means that I'm giving you something that's a unit circle value. 60 degrees is one of my unit circle angles. So I'm going to go to 60 degrees on the unit circle. The coordinate at 60 degrees is 1/2 square root of 3 over 2. Now remember, the C is standing for cosine, S is standing for sine. And if you recall, the x value is our cosine value and the y value is the sine value. So I'm going to go ahead and write it or convert it by doing 9 times 1/2, because 1/2 is cosine of 60 degrees, plus 9, forgot the 9i, times square root of 3 over 2. So this was the x, remember? Oh, sorry, I thought I was on highlight. That was the x. This is the y. Okay, so all I have to do now is just simplify that. So this is 9/2 plus 9 square root of 3 over 2i. That's your answer. You've converted it and everything. Let's go ahead and do another type like that. So this problem, same thing. At the end, we're going to convert it to standard form, also known as rectangular form. But let's do the operation first. So we're raising it to the 5th power this time. So we've got 2 raised to the 5th. And then I'm going to multiply 5 times 4 pi 15ths. 2 to the 5th is 32. And then 5 times 4 pi 13ths is 4 pi over 3. And then you'll notice once again that this is a unit circle angle. So I'm going to go to my unit circle. I'm going to find 4 pi thirds, or I'm going to figure out the coordinate for 4 pi thirds. The coordinate is -1/2. It's here in the 3rd quadrant. So -1/2, negative square root of 3 over 2. And then I am going to convert this. So to convert it, remember the C stands for cosine, which is the x value. So 32 times my x value plus 32 times my y value, 32i I should say, times my y value. And remember the y value is the sine value in the unit circle. So that's where I'm getting all those numbers. And then we just simplify that. So this is just -16 minus 16i square root of 3. And it's converted. It is in standard form and everything. Now we have one more operation we're going to learn. Before we learn that operation, it's just complex roots. I want to talk about how to convert, or just review how to convert complex numbers. We're used to converting non-complex numbers. So in the past, we'd have something where it was like 4 square root of 3, and I'd tell you to convert that into polar form. This problem is really essentially the same. This is my x, this is my y. So I could write it as a coordinate 4, and I'm going to convert that coordinate just like we did on the very first lesson of this unit. So we've got 4 squared plus 4 squared, because remember x squared plus y squared is equal to our radius squared. So 16 plus 16 is 32. So let's write that. 32 is equal to r squared. I'm going to take the square root, And you get the r is 4 square root of 2, which, if you notice, we had 2 4 squared, so that should be our answer in the end. Then to find our radius, or not our radius, our angle, I just think of the unit circle, because generally these are usually something that's on the unit circle, and this one will be. The reason I can tell is because they're both a distance of 4, which means it's an isosceles triangle. That tells me this is a 45-degree angle, or right in the middle. Now I'm going to put it in terms of radians. I didn't say to do that, but most of the time, unless I say otherwise, we use radians. So 45 degrees is the same as pi fourths in radians. So I need to convert this. I don't convert it as a coordinate. I convert it as a complex number. So to convert this as a complex number, I'll write the radius, which is 4 square root of 2. And then I'll write it the long way rather than the shorthand, but it'd be cosine pi fourths plus I sine of pi fourths. And that would be our final answer. That's all you'd have to do if I ask you to convert.